Hello students, very good morning. So today's session we will discuss a very important topic in inorganic spectra of metal complexes of multinuclear NMR topic. Here we will discuss some of the very important examples of F19 NMR spectroscopy, the examples of BRFI, PFI, SF4, BF4 minus and ClF3 molecules we will discuss. So these examples are very important in the competitive examination point of view. So we will discuss. So in this F19 NMR spectroscopy, so generally the abundance of fluorine is 100% and so F19 is a NMR active. The nuclear spin value I is equal to 1 by 2. Okay, clear student, right? It is NMR active. F19 is NMR active. Okay, right. So generally in this F19 NMR spectroscopy, fluorine 19 NMR spectroscopy, so we are using a reference compound that is CFCl3. So that is a trichloro fluoromethane is used as a reference compound. It is high volatile and inertness compound. So this CFCl3 is used as a reference compound in F19 NMR spectroscopy, right? So the range of chemical shift of F19 NMR spectroscopy, that is 0 to 200 picometers. Okay, right. So in this F19 NMR spectra is a simple first order spectroscopy. It is not a two dimension. It is a simple first order spectroscopy. It is not a 2D spectroscopy, right? So we will move to the example, student. So this is a PFI molecule. So it is a PFI. So that is a phosphorus penta fluoride, phosphorus pentafluoride. It is a PFI molecule, right? So generally what we have observed in this PFI molecule, student. So generally at room temperature, so that means room temperature means nothing but, student, at 27 degrees temperature, it gives only one signal. It gives only one signal. So that means it gives only one signal in F19 NMR spectroscopy, but it is coupling with phosphorus. It is coupling with phosphorus and it gives doublet. So this singlet is splits into doublet. So with the coupling of this is F19 NMR spectroscopy, but when this each single signal is coupled with this phosphorus and it gives PF. So that means it gives a doublet in NMR spectroscopy at room temperature. So why? Because, student, at room temperature all the fluorine atoms are in chemically equivalent environment. So chemically equivalent environment, chemically equivalent environment, chemically equivalent environment. So due to this chemically equivalent environment, all the fluorine atoms are in equal environment. So therefore NMR spectroscopy recognize only one. So that's why it gives a singlet. But this singlet of fluorine NMR, so is coupled with the P31. So then it splits into doublet. Okay, right. But when we decrease the temperature, so means at minus 20 degrees temperature, student, at minus 20 degrees temperature, the compound is freeze and it is shows a perfect trigonal bipyramidal geometry. It shows a perfect trigonal bipyramidal geometry. In this trigonal bipyramidal geometry, student, the two fluorine atoms are axial fluorine atoms and the remaining three fluorine atoms are equatorial. So here we have two axial. So the two fluorine atoms are axial fluorine atoms and the three fluorine atoms are equatorial. Okay, not Fe. So it is equatorial. So three fluorine atoms are in equatorial and two fluorine atoms are in axial, right? So we will discuss about axial, then we will move to the equatorial side, student. So these axial fluorine atoms are coupled with the phosphorus and it splits into a doublet. So means according to the n+1 formula, so these fluorine atoms are coupled with P31. So that means n+1. That means it splits into a doublet. So this is PFA. Okay, right. So each this singlet again coupled with the 3 equatorial fluorine atom. So therefore, each further splits into n plus 1 formula. So that is splits into quartet, and this is also splits into quartet. So means the 3 equatorial fluorine atoms are there. So therefore, it splits into 3 plus 1 signal. So that means it gives quartet of quartet, quartet of quartet, quartet of quartet, right? So this is belongs to axial set of protons, fluorine atoms. That equatorial, student. So similarly, so it coupled with the fluorine atom. So that means J phosphorus coupling of equatorial. So coupling with the equatorial of fluorine atoms coupled with the phosphorus, and it gives a doublet. And this singlet, each singlet is coupled with the equatorial axial set of fluorine atoms. So therefore, the each singlet is further splits into triplet. So this is splits into triplet. So this is gives rise to the coupling of equatorial protons. Equatorial fluorine atoms are coupling with axial. Here the coupling of axial fluorines are coupled with equatorial. So therefore, it gives a triplet of triplet, triplet of triplet in F19 NMR spectroscopy, triplet of triplet in NMR spectroscopy. So this is about F19 NMR spectroscopy of BFI molecule. So please clear, student. So at room temperature, it gives only one signal. When it is coupled with the F9 phosphorus, then it gives its doublet. But when we decrease the temperature, that means at minus 20 degrees temperature. So here we have the two types of fluorine atoms are there. So axial and equatorial. So two axial fluorine atoms are coupled with equatorial fluorine atoms, and the equatorial fluorine atoms are coupled with the axial set of fluorine atoms. Okay, so this axial set of fluorine atoms are gives a quartet of quartet, and the equatorial fluorine atoms gives a triplet of triplet. So this is about PFI molecule, student, right? So next, so BRFI molecule, student. So generally, the BRFI molecule shows two types of possible structures are there. One is trigonal bipyramidal. So this is trigonal bipyramidal, student. So this is trigonal bipyramidal, and so this one is a square pyramidal geometry. So this is a square pyramidal geometry, square pyramidal geometry. So one is trigonal bipyramidal, another one is square pyramidal geometry, right? Similarly, student, so before we have discussed in the case of PFI molecule. So here we have in BRFI molecule, so the two types of fluorine atoms are there. So equatorial and axial set of fluorine atoms, student. So generally, bromine is not NMR active, student. So therefore, here it gives two different kind of NMR spectra, student. So this axial set of fluorine atoms, axial set of fluorine atoms are coupled with the equatorial. So then it gives a quartet. So that is you can see. So this is 1:3:3:1, and so this is belongs to axial set of fluorine, and then so these equatorial fluorine atoms are coupled with the fluorine atom. So therefore, it gives a triplet. So that is 1:2:1 intensity ratio. So this is belongs to equatorial. So that is 1:2:1, and this is 1:3:1 intensity ratio. Clear, student? So this is about trigonal bipyramidal. Okay, so for trigonal bipyramidal structure, student, so two signals are possible, and the intensity of the signals is 2:3 ratio, 2:3 ratio. Okay, so that means 2:3 ratio means nothing but axial fluorine atoms and equatorial fluorine atom. Okay, so these axial fluorine atoms are coupled with the equatorial, and equatorial fluorine atoms are coupled with the equatorial fluorine atoms are coupled with the axial. So then it gives a quartet of a triplet, a quartet of triplet, quartet of triplet, student, right? So here in this case, student, for square pyramidal, student, so two signals are possible with 1:4 intensity ratio. So this is 2:3 intensity ratio. So this is 1:4 intensity ratio, student. So here we have only one axial and 4 equatorial fluorine atoms are there. 4 equatorial fluorine atoms are there. So therefore here you can see, student, so one axial fluorine atom is coupled with the 4 equatorial fluorine atoms. So therefore it will give a quintet. So it will give a quintet in the NMR spectroscopy. It gives a quintet in the NMR spectroscopy. So it is belongs to the axial fluorine atom, and so the 4 equatorial fluorine atoms are coupled with the axial fluorine atom. So therefore it gives a doublet in the NMR spectroscopy with a 1:1 intensity ratio. Clear? So this is a quintet, and so this is a doublet. It is a doublet in the NMR spectroscopy. So this is about a square pyramidal and trigonal bipyramidal, the possible geometries of BRFI molecules. Okay, right. So next we will and also we will conclude, student, we will conclude. But when we record the spectra by taking BRFI, so we will get two signals as a quintet and doublet, which correlate square pyramidal structure. So therefore generally the BRFI molecule exhibit a square pyramidal geometry, not trigonal bipyramidal geometry. So this is the evidence of NMR spectroscopy. Clear? So therefore the BRFI molecule exhibit what kind of geometry, either trigonal bipyramidal, square pyramidal, or square planar. So generally it exhibit square pyramidal geometry according to the F19 NMR spectroscopy. Clear, student? Right. So next we will move to the another example. So this is SF4 molecule, student. So here it is exhibiting the different types of geometries. So that is okay, right here. So SF4 molecule. So this is SF4 molecule. So this is a very very important example in F19 NMR spectroscopy, student. So generally SF4 molecule shows four possible structures. Four possible structures. So four possible structures are there. So that is trigonal tetrahedral, square planar. So this is square planar, and this is tetrahedral TD, and this is a trigonal bipyramidal, and here we have one lone pair. This is a seesaw model. Seesaw model. So here we have the four different types of geometries, but according to the F19 NMR spectroscopy, so which geometry is suitable for SF4 molecule? So okay, right. So here you can see for tetrahedral molecule, all the fluorine atoms are chemically equivalent and magnetically equivalent, and it gives only one signal in the NMR spectroscopy. Right. Next, in square planar complexes, in square planar geometry, all fluorine atoms, here it is chemically and magnetically equivalent, but here so chemically equivalent, so it gives only one signal in the F19 NMR spectroscopy, right? So next, in the case of SF4 molecule of seesaw model, student. So in this seesaw model, we have two types of fluorine atoms. So one is axial and another one is so these are axial, and these are equatorial. So equatorial and axial set of fluorine atoms are there. So simply you can write so that is axial and equatorial set of fluorine atoms are there. So therefore we know very well, student. So generally according to the n+1 formula, so generally the sulfur is not NMR active. So this is NMR inactive. So therefore fluorine cannot coupled with the sulfur atom. So therefore only the fluorine atoms are coupled with the equatorial is coupled with the axial, and axial is coupled with the equatorial only. So here you can see, student. So here I am writing about axial fluorine atom. So here these two axial fluorine atoms are coupled with the two equatorial fluorine atoms. So therefore according to the n+1 format, so it gives a triplet. So it gives a triplet. So that means it gives a triplet in the NMR spectroscopy with 1 is to 2 is to 1 intensity ratio, right. So next here you can see student, so this is axial set of equatorial set of proton. So here we have two equatorial set of fluorine atoms are there. So these equatorial two equatorial fluorine atoms are coupled with the two axial fluorine atoms. So therefore according to the n plus 1 formula, so it gives a triplet. So therefore in the seesaw model, it gives a triplet of triplet, it gives a triplet of triplet, it gives a triplet of triplet in NMR spectroscopy. Clear student? So and so you can go for this trigonal bipyramidal geometry student. So in this trigonal bipyramidal geometry, so one axial and axial fluorine atom is there, and the remaining are here. I will show like this. Here you can see this is the fluorine, sulfur, and this is Fa and Fe, and so this is equatorial fluorine. So therefore here we have two types of fluorine atoms. One is axial and the three are equatorial. So therefore if these axial fluorine atoms are coupled with the three equatorial fluorine atoms, so therefore it will give a quartet in the NMR spectrum. And so three equatorial fluorines are coupled with the axial fluorine atom. So therefore it gives a doublet in the NMR, doublet in the NMR with 1 is to 2, 1 is to 1 intensity ratio. Okay, clear. But in this F19 NMR spectroscopy, so which is the possible model? So that is seesaw model is correlates with the F19 NMR spectroscopy. So therefore SF4 molecule shows seesaw model. Clear student? So therefore the possibilities are trigonal, bipyramidal, tetrahedral, square planar, but as per NMR studies, so SF4 molecule exhibits seesaw model is the correct model. Clear? Right. So next student, so we have BF4 molecule. So with two different NMR activity. So generally, so it is isotope. Boron is isotope. It exhibit B11 and B10 student. So generally for B11 and B10, so we will discuss student. Right here you can see. So generally for B11, the nuclear spin value is 3 by 2. For B10, the nuclear spin value is equal to 3. So this is the difference between the boron 11 and boron 10 isotope student. So generally, so these are the fluorine atoms. All the fluorine atoms are there. So in this fluorine atoms are coupled with the boron. So therefore here, the according to the 2Ni plus 1 formula student, 2Ni plus 1 formula. So here you can see 2 into 1 into 3 by 2 plus 1. So because all the fluorine atoms are chemically equivalent, so therefore these fluorine atoms are coupled with the boron 11 isotope. So therefore it gives a quartet in the NMR spectroscopy. So it gives 4 lines in the NMR spectroscopy. Right here you can see student, all these fluorine atoms are chemically equivalent. So therefore these 4 chemically equivalent fluorine atoms are coupled with the boron 10 isotope. So therefore 2 into we have only one boron atom, but the I value is 3. So in plus 1. So therefore 2 into 6 plus 1. So therefore it gives 7 lines in the NMR spectroscopy, right. So it is isotopic shift due to the, right here you can see. So this is 1, 2, 3, and here you can see. So this is a heptate and a quartet in the NMR spectrum of BF4 minus molecule. So BF4 minus molecule. Clear student, right? So next we have one more example student. So that is here I will discuss the another example for this NMR spectra of metal complexes student. So that is we will go for a ClF3 molecule student. So here I will write ClF3 molecule. Here you can see. So this ClF3 molecule student. So here I will draw the structure. So that is Fa, and here this is Fe, and this is Fa. So here we have the two axial fluorine atoms and one equatorial fluorine atoms are there. So it is very simple student. So these two axial fluorine atoms two axial fluorine atoms are coupled with. So here it is not NMR active. So these two fluorine atoms, axial fluorine atoms, are coupled with the equatorial. So therefore it gives a doublet in the NMR spectrum, and one equatorial fluorine atom is coupled with the two axial set of fluorine atoms. So therefore it gives a triplet in the NMR spectroscopy. It gives a triplet in the NMR spectroscopy. So therefore it gives a doublet of triplet. So it gives a doublet of triplet in the NMR spectroscopy. Doublet of triplet, doublet of triplet in the NMR spectroscopy. Clear, student? So these are very important examples in F19 NMR spectra of inorganic metal complexes, student. I hope this lecture is very important for entrance examination point.